Hello, champions! It's another interesting basic science class with Miss Andres. You are welcome, welcome, welcome. And today we are going to be looking at gears. What did I say? We are going to be looking at gears. Now, what do we understand by gears? Now, a gear is similar to a pulley, meaning they both have a wheel and an axle. But there's something extra that a gear has that a pulley does not have. Do you know what it is? It is they have teeth. What did I say? They have teeth around the perimeter of their wheels. Now, when you talk about perimeter, what does it mean? It means the outside edge of an area or surface. So the difference between a pulley and a gear is in their structure, which is a gear has teeth around the perimeter of their wheels. Now, a single gear on its own is not able to accomplish any work, so they have to be joined together. So gears have to be meshed. To be meshed means to be locked, to be connected together. And when they are connected together, they can be used to change direction of motion, it can be used to increase force, or it can be used to increase speed. Okay, and now for this to happen, that means the different gears, their teeth must interlock, it must fit, it must work together. You understand? And as it's working together, it causes a rotary, that round movement. And this is also known as torque. Now, one thing must know is that gears that are paired together in a system are called gear train. What did I say? When gears are paired together in a system, it is called gear train. Now, gear trains have at least one driving gear and one driven gear. So a gear train is made up of a driving gear, an idle gear, and a driven gear. So the idle gear is always at the middle, it's always in between the two gears. That means it's always in between the driven gear and the driving gear. Now, this driving gear is also known as the input gear, and the driven gear is known as the output gear. All right. So the driving gear is known as what? The input gear, and the driven is known as what? The output gear. Now we have different types of gears. What did I say? We have different types of gears. There are very many types. Now these different types of gears have been invented to suit different purposes. All right, but we're only going to be focusing on three. What did I say? We're going to be focusing on three. Now, some gears can be used to increase force, like I said. Some are used to change the direction of motion, while some are used to increase speed. Okay, so they are SPUR gear, rack and pinion gear, and worm gear. What did I say? SPUR gear, rack and pinion gear, then worm gear. So look at these gears one after the other. Now we'll be starting with SPUR gear. Now a SPUR gear is the most common type of gear. You can be asked, what is the most common type of gear? What will you say? A SPUR gear. Now these gears, they can be found around you. It's not something you've not seen before. So if you have a washing machine, a SPUR gear is inside. So it can be found in a washing machine, it can be found in clothes dryer, it can be found in wind-up clocks, and it can be found in electric screwdrivers. So you can be asked, which gear can be found in washing machine? What will you say? SPUR gear. Beautiful. One characteristic feature of a SPUR gear is that it has parallel axes. Parallel, when you say parallel lines, they don't meet. A SPUR gear has parallel axes and it has straight teeth. Remember, the teeth surrounds the wheel of what? Of a gear. Now, these gears, they make noise, loud noise as they turn. So as the teeth collide against each other, remember, one gear does not work alone. It has to be two or more working together. They collide against each other. These gears, they are known to make loud noises. If they make loud noises, meaning it's not very efficient, don't you think so? Something that you are using and is making a lot of noise is not very, very efficient. So we have helical gears, are a variation of SPUR gears. They are examples, they are types of SPUR gears. Now we'll be looking at the next one, rack and pinion. Repeat after me, rack and pinion. Now, a rack and a pinion is the most commonly used to steer vehicles like cars and trucks, because gears can also be found in vehicles and trucks. So the ones that are used in vehicles, cars and trucks are rack and pinion. Did you get it now? Now, what do? They allow rotary motion to be converted to linear motion. Now, rotary has to do with going in circles. Then linear has to do with moving in a straight line. So if you see a rack and pinion, you will see a round wheel, then you will see a straight gear too being attached. So what a rack and pinion does is that it will convert that rotary, that round motion movement, to what? To a straight movement. You see it now? So the wheel, alright, that's that circular one, the rotational part, is known as the pinion. While the straight gear, that straight one, now you can see this picture now. You can see a round gear and you can see a straight one. So the round one is the what? The pinion. While the straight one is the what? Is the rack. So do not get it confused. The round one is the what? The pinion. And the straight one is the what? Is the rack. So movement will usually begin from the wheel. So as it is spinning, spinning round, the teeth will mesh up. You see it? Remember I told you what meshing means? Meshing means to connect, to lock. You see it? So it will connect with the straight gear. Alright? So, and as it's moving, it can move to either the left or to right. So as it's rotating, it can rotate to either the left or the right. This causes rotary motion to get converted to linear motion. So you can see it, the rotary motion is converted to linear motion. Now the next and the last one we'll be looking at is worm gear. What did I say? Worm gear. Now a worm gear is a combination of a circular gear and a cylindrical shaped gear. You know what a cylinder looks like? It's long and rectangular in shape. Alright, so this looks like a screw. A cylinder is long, is thin, and is rectangular in shape. Now these types of gears are great for generating a lot of torque, that's a lot of force. They are good to generate a lot of force. Now the worm drives the wheel, but the wheel cannot drive the worm. So that cylinder shaped gear is the worm. So this makes them great in locking mechanism. For example, they can be used to run conveyor belts in factory. Okay, they can also be found at the end of guitars to tighten strings and keep them from slipping out of tune. So it is a worm gear that is found in guitar, and it is also a worm gear that is found in conveyor belts. Remember, the worm drives the wheel, but the wheel cannot drive the worm. Now, how do gears work? Remember we said we have different gears and every of these gears function differently. Okay, now remember a gear train we said is when gears are paired together in a system. So in order for a gear train to function, it must first be driven by some sort of force. Remember we have the input gear and we have the output gear. The input gear is the driving gear, while the output gear is the driven gear. So we're going to be looking at a common example, bicycle. Now a bicycle is a great example of a crank-powered gear train. If you look at a bicycle, if you look at where the wheels are and the pedals, you will find out that there is gear there. You will see that there is teeth. How do you know a gear? Teeth is always around their wheels. So in a bicycle, the gear teeth are meshed together with chain, using a chain. You see it now? So the gears are not touching each other now, but instead the gear is attached with a chain. So in a way, they are like a pulley system. Alright, so it's just like you're having a pulley system and a gear working together. So the person's leg, as the person is pending the bicycle, is supplying the force which is needed to drive the input gear. So the effort the person makes is now transmitted to the output gear. And remember, the output gear is the what? Is the driven gear. Okay? So which is now attached to the back wheel, the wheel of the bicycle that makes it to spin. So you see the way a gear works. Force must be supplied. When force is supplied, it gets to the what? To the input gear, which is the driving gear. So from there, effort is now transmitted to the output gear, which is the driven gear. Okay, so with that, the tire, the back wheel begins to spin. In the bicycle, the chain is acting as an idle gear. Remember, we said the idle gear is always in between the input and the output gears. In a machine-driven gear train, the driving gear is attached to an axle that is attached to an engine or a motor that generates rotary motion. So the gears transfer that motion through other idle gears to the output device, such as a wheel on a car. Alright, so that explains everything that I've been saying using a bicycle. The next we're going to look at are the benefits of using gears. What do you think is the benefits? Number one, they can change the direction of motion. Number two, they increase force. Number three, they increase speed. So these are some advantages or benefits of using a gear. Gears can be used to gain a mechanical advantage, which means they can give you large output force for small input effort. So lastly, for this topic, we'll be looking at the effects of using gears. Some machines that use gear, they require the burning of fossil fuels. Remember, fossil fuels, they have negative impact on our environment. So how do we go about this? It is our responsibility to manage how much we are using and relying on these machines in our daily lives. Okay, so try as much as possible, especially vehicles and all, try as much as possible to reduce the way we use those machines. Instead of using cars, you could decide to walk to school, or you could decide to use your bicycle. So it's a form of exercise. Now we've come to the end of this class. Remember, we started by talking about gears. Then we looked at different types of gears: spurs, worm, rack, and pinion. Then we looked at benefits of using gears: increased force, increased speed, the change of motion. Then we ended by looking at the effects of gears on the environment. Now I know you have a better understanding of this topic. Thank you for watching. Do not forget to attempt your quiz and do your assignment. Bye.